All right, first of all, we're talking about electricity and water today. Electricity is a huge, wide subject. We're not going to cover anything except alternating current, 120 volt, and water and the dangers that such combinations can bring to us. But we've got to start with a little bit on basic electricity here, naturally. And so here I have a typical plug. You've seen these before. You don't often see the wires loose. Some do, I do, but maybe not everyone. And what you usually have, a typical 120 volt AC circuit has three separate conductors. One is the earth ground. The second is called neutral, and the third is the hot. So those are the three circuits. And so they're typically color coded the way you want them to be. And so there's a green for earth, green like Mother Earth. Black for death, that's the hot. The neutral is white, it's angelic. Now why is it angelic, you wonder? And why is the other one death? Because back at the power station, who knows how far away, when they generate electricity, they send it out over transformers and telephone lines, or not telephone lines, but electrical lines and so on. And at one point there, as it gets close to the place where it's going to be used, they bond the earth ground. First of all, they tap a big metal rod into the ground, so it really is earth ground. They pound it in like 6 feet down with a copper rod, and they tie that to your ground wire. And then, surprisingly enough, they also tie the neutral at the same place. So at the origin of most circuits like this, now not all, some are not grounded properly or not grounded for various other reasons, but when you start out a circuit, it's typical to expect that the neutral is the same as the ground. They sort of are. The hot, on the other hand, now that's the one that carries the actual dangerous part of the electrical circuit, because it's 120 volts with respect to ground. So if you're just standing on the ground, and if you have a contact ground, and you touch the hot wire, a hot wire, bzz, you're gonna get 120 volts. It's not gonna feel good. Is it gonna kill you? Well, maybe not if you're on land. If you're in water, it might, because it can paralyze you and put you out. You all know that, I'm sure, already. Now, on the other hand, if it's plugged in, it's doing its thing, and you grab the white wire, not a problem, typically. But not always, but typically it's not a problem. And typically not a problem to touch the earth wire too. Now this is all assuming they're properly connected. And that's where problems occur, as wires come disconnected over time. So you can have circuits that are properly wired, but then time goes on. Pretty soon you get corrosion. Somebody hits it with their car, who knows what, jogs it loose, and pretty soon one or the other of the wires can come loose, and that can cause you problems. So that's what we're going to get more into here, and how it is particularly a problem with boats and water. So, enough of the general purpose stuff. Also, just another quick note on the way you can talk about electricity, and that's that often people talk about electricity similar, and you can use an analogy to water and a hose. So, like if you do look at that analogy, when the pressure of the water through, so your water pressure is the voltage, and the water flowing through the hose is the current. Okay? And so the combination of those two things, when the current flows along and it encounters a load, let's say a propeller or an impeller, or I don't know what else you do with a hose, but something you wanted to spin, that's your load, and that uses the energy. So anyway, but that's just a little aside, not that interesting. And really, it's not a very great analogy if you really knew your electricity, but people talk about that quite a bit. Okay, now here's what we have. We have here a typical boat situation. Now, this guy here will be connected to your shore station. And as I said, there's three wires here. There's a black, and you know what the black is, right? Death, hot, danger. The white, neutral, angel, whatever. and the earth is a safety ground. And they send this earth along to try to keep everything safe. And normally it does. It does a fine job for you. And on this other side, when you bring water from... Are we back in business then?
We're back.
All right, so anyway, people like to have electricity on their boats so they can run their air conditioners, their bilge pumps when they're not there, because your battery runs dead and your bilge doesn't work, you're in screwed land. But so there's reasons that you want 120 volts on your boat if you're leaving your boat in the water all the time. And so typically there's a pedestal or some sort of thing that you plug into, and then the other end goes to your boat. And there's a, like any 120 volt circuit, hot, neutral, and the ground. And on a boat, you want things to be safe because people worry about getting shocked on boats, naturally. And so what happens is the green wire, the earth wire, is attached up to the pedestal, which is attached again to a copper rod probably going into the ground, probably.
Hopefully.
Yeah, hopefully. And at any rate, this green wire then is always going to be safe. And so what they do is within a boat, they have a grounding system within the boat where they ground all of the things in the boat, like the external part of it. Let's say you had a refrigerator. You would have a wire from the outside of the refrigerator, the metal part of the refrigerator, to the earth ground in the boat. And any other device, there's always a safety ground. So
where is that located at in the boat?
The wiring, it's down in the bowels somewhere that you won't usually see.
Okay.
They have these big fat, well usually it's a thick double lot, which is thick copper cables in there, and they bind everything to that because safety is a key thing in a boat here. Not really. And that's also would be true of say air conditioning units and things like that take the power, but they also will have, so they'll get a hot and neutral, which are the two pieces of the circuit that actually do the job. Now, a little while ago, I said that the neutral and the ground were sort of the same. Well, they're not really, because the intent and the use of the ground, the earth, is always no current should ever flow in that unless there's a fault. And if there is a fault, well, then the earth will do its job. And normally, the power goes from the black of the hot, and then it's returned through the neutral. So the way electricity works, just another little bitty thing, is that if you're gonna power something, it goes out, but it has to come back too. You have to complete the circuit. So there's always a circuit. If you're gonna run electricity through a load, let's say a compressor on a boat, it has to come from somewhere via the hot, and it'll return through the neutral back to whence it came.
But it doesn't usually go into the ground.
Oh no, in fact, you don't want it to go in the ground. And
because that will complete the circuit? Will that complete
well,
the
yes, it would. It would actually work too.
Yeah.
But it's not safe, and we'll show you why in a minute.
Okay.
It's not always safe anyway.
Okay.
But an interesting bit about this is that a ground fault interrupter circuit, you've heard of GFIs or that's not.
Yeah, like in the kitchen.
Yeah, the way that works is the power goes out the black and back through the white after it goes to your refrigerator or your coffee maker or whatever, and so that's the circuit goes round in circuit. Now, a funny thing here is that AC current doesn't really do that. It washes back and forth. We'll forget about that. But that's okay. At any rate, so the white and the black are the circuit path. Now, on a GFI circuit, what happens is if you do get a short and the GFI circuit detects that there's current going out the black, but it's not coming in the white, it says, ho ho, something bad's going on, and breaks the circuit. So that's how those work. So a GFI circuit is a wonderful thing.
Safety.
Yeah, because the earth is nice and all, but the GFI goes even beyond that.
It's more
It's more
reliable,
comprehensive,
right?
you might say, yeah.
Less variable.
Yeah. So at any rate, but a lot of the if your source where you plugged your boat into doesn't have a GFI, and probably
So is that all that's going on with the new improved electric systems at docks? There's a GFI
I think
and
that's
an alarm. That's it.
I think that would be what I would do, certainly. Now, whether that's what's actually happened, probably.
Oh.
But they also probably go through and they make sure that the grounds are properly attached and the earth is properly attached and so on. But whatever.
Right.
Anyway, let's carry on here a
Yeah.
little bit more and talk about how we can get in trouble. Now, as I said, in a boat, you have a earth ground coming in, and you have like a ground bust through the whole boat, and then they take that earth ground and now this wire here is a little misleading because there's only one wire, goes from this earth ground into the water.
What?
The
Yes.
anode.
They actually have an anode, a plate, a bonding plate typically, that they use as a conducting surface to attach, to ground the boat basically.
Huh.
So the boat itself and its electrical circuits are grounded through this green wire usually it's attached to part of the engine or a separate anode or something that goes into the water. Anyway,
It seems like an obvious flaw.
well, there's good reasons for it.
Because it's like,
What
is
are
it like,
those?
like
Well, I'm not going to cover the good reasons because I can't really think of them offhand. Well, part of it. See, here's the thing: is you don't want your boat's potential to be floating, because let's say you didn't ground your boat to the water. Well, then, I don't want to go into why exactly they need to do that, but they do need to do that. It's an essential part of the safety circuits. It's a requirement when you wire up a boat.
Okay.
If you're going to have 120 volts, it has to have a way. It has to have a grounding path back through the water. Now that's where the problem is, isn't it? Because here's what happens. As I said, when you have the power coming in, normally it goes out the black, back in through the white, and everything is great. Now, if you had, though, a circuit flaw, and let's say that the white wire breaks, so your neutral is gone kablooey, it got corroded, it fell off, somebody kicked it, who knows what. Well, now what happens is the juice goes out the black wire, does its business, and then the device here will operate like normal, and the current will return through the ground. Okay, so it'll go like right through your load and back out the circuit. But now it's
kind of
not.
like what it would do instead of going through the.
Instead of going through the white, it's going
How
through the
come
ground.
so it doesn't make it into that other green?
No.
It's back to the.
It hasn't yet. That's right. Because then what happens is that you're sort of safe then, as long as you have your earth ground solidly connected to the earth ground that's in the pedestal, and that's connected via some rod down deep into the earth, then you're nominally okay as far as being in the water goes. Anyway, and so the current will be flowing incorrectly. It'll be flowing out the hot and back through the neutral. But what can happen too is that then perhaps the green wire comes disconnected. Now all you have is a hot wire going into the boat, and the other two wires are doing nothing useful. But you do have this bus bar, within the boat that's then connected to the water, and that water is connected to, there's a path through the water to earth ground back at your circuit there, and it'll find its way back through here, back around the boat, through the water.
To try and complete the circuit?
Yeah, it has to complete the circuit, yeah.
It wants to complete the circuit, and that's where, okay.
Yeah, exactly, and then so then it'll come through, now, so for that to happen, again, you have to have it has to be connected, and the ground has to not be, and then you have to have a break in the circuit. Things aren't always, older boats, whatever, things aren't always properly grounded. They get old, they get crappy, who knows what. So you don't know what's going to go on. So what could be happening is you could be powering your refrigerator this way. Now, if it's going back, what'll probably happen is that path through the water is not particularly efficient. So there's a good chance that
Air conditioning is
something like that could happen. So
Okay.
it might not really work properly. But still, you still have that current flowing, will still be flowing through. So that's a way that you can get zapped in the water. And of course, if you're in the water and electricity comes through, depending on the strength and the nature of it and where you are in the water, can be paralyzing. Yeah. And so you just simply can't swim and you go blah blah.
So, like, what would happen if you had two boats that were having a fault? Would that like amplify the? I mean,
you'd have two different paths through the water because it doesn't go everywhere through all bits of water. It typically finds a path back through.
Well, it doesn't necessarily go back to the power pedestal area.
It could go to
wherever it can go, wherever it can
go to a
complete the
different
circuit.
one. Yeah, it could go to a different one or a boat next door potentially.
Or metal in the water, or no?
Yeah, why not?
Oh.
Anything in the water. Yeah. So all right, well that's all really bad. Now you might think, that's cool. I got a tester.
Mm-hmm.
I ain't gonna worry about this at all. And so you have a nice testing device, like we have one over here. I think this is called a shock alarm.
Yep.
And a superb device. You have to give the people credit for this. And what you have to do, if you put this in the water, it's got intelligent detection circuits in it that can detect the fact that there's stray electricity in that water that doesn't belong there. And it'll put out an alarm. And so that's fine. And so if you detect that, don't go in the water. Now here's the reason that that's not 100%. It's not going to save your skin all the time. Because, as I said, the problem happens when there's a short from the hot to the ground via some means or another. Now, if it's on the unswitched side, okay, because when it comes in the boat, there's no switch between
Right,
here and
it's
there.
just
But,
it's giving the current.
but let's say you might have a light switch that turns on lights, or a temperature sensor that opens and closes depending if your refrigerator needs to run or your bilge pump needs to run. So it might not be on all the time. And so if the side that's always on is where you get the short to the ground and then has to go back through the water to the pedestal, that's fine. Your detector will detect it. But if it's on the switch side, when you're testing it, your refrigerator may not be running. So the switch may not be closed and this side of the circuit may not be energized. And so, and if your short is on this side of the circuit, then what can happen is, it's all dandy dandy. But then somebody turns on the refrigerator and bzzz, now you suddenly have water going through for a short period of time.
So like the bilge pump would be a good example,
Yeah,
right?
that's
It's like
another
it knows it needs to kick on at some point because
sure.
like whatever, right?
Yeah, it's got a switch in there.
So you're
that's
saying,
water
like,
level activated, yeah.
So like you've got the power coming in, and the bilge pump at that point is off because it didn't need to be running on the switch side, right?
Yeah.
But then it's like, oh wait a minute, I feel water. Like
That's right.
I gotta turn on, and then it kicks on, and then the short comes from that.
Yeah, that's right. If the short's over on the switch side of the circuit there, then
So how do you prevent that from happening?
well, stay out of the water. A. Now, if you can't do that, then the safest thing is to disconnect the entire boat.
Okay.
Because if the boat has nothing attached to it, then that means it has no hot wire going
Okay.
anywhere.
Okay.
That means actually unplugging it and whatnot.
Okay.
Well,
That would be typically true. So that's the safest way to do it, to completely disconnect.
what's the difference between disconnecting it and flipping the breaker?
Well,
it
because the
matter?
breaker, see the thing there is that it's possible that
Still some sort
there
of.
could be a fault in the pedestal if it's not brand new, if it's not nice and spanky new and whatnot.
But if the fault was in the pedestal, the shock alarm would pick it up. Because
Right.
it
Yeah.
would be.
Because the
it would be
hot
coming
was
from
still
that
coming
side.
through.
Yeah, yeah. that's
Okay.
right.
Okay.
Yeah, if
So it wouldn't be like.
if it's in the pedestal or anywhere, as long as it's getting in the water, the shock alarm will pick it up. It doesn't
Yeah.
matter where the fault is. Yeah, if it's in the pedestal, sure.
Okay.
What about, so now like, okay, this might be a stupid question, but so let's say the bilge pump is running on a battery. The battery isn't going to be strong enough to deliver, because this is 124.
Yeah, how come the
120 volts.
battery? How come it's not an issue with the batteries?
Well, the batteries are a 12-volt system. First
Okay.
of all, they aren't going to give you a shock in the water. You
So
can
even
put
if
your-
it did go in the water, it's no problem.
You can put it on. You can put a
You can
12-volt
just lick
battery
it.
on your tongue and get a little
Okay.
shock. It's not
Yeah,
gonna,
okay.
it's not going to
That makes
paralyze you and so on.
Okay.
Now, an interesting thing is, and I haven't really thought about this too much, is that if you really do have a good pedestal that has a solid ground, and everything is intact, then your ground wire and your ground in the boat protects you completely. Okay. The fact that it's connected to the water as well doesn't matter, because that's a relatively high resistance path. When you're talking about resistance, you might talk about, if you're talking about water, would be the size of your hose, let's say.
Okay.
Mhm.
So if you had a tiny little hose going this way and a big hose going back to the pedestal, well, the water's mostly going to go back this way. Not 100%, but mostly. And so you're probably okay. So if you're plugged in and you shut off the switch, okay, what you're really doing is you're disconnecting the hot, but you're leaving the ground intact. So that's kind of
So
a good
there's
thing
still-
too.
Okay.
So that part's actually good. So it's a little unclear to me. If you unplug completely, it's like, wow, great. My boat knows nothing about 120.
Mhm.
To me, that feels like the ultimate safe, because you don't have to worry about the pedestal, whether the grounds are good, whether there's any problems with your wiring anywhere in the system. Because hey, there ain't no juice coming in or then going through the water to get back out.
So, with that being said, then, because we've experienced it from different pedestals, like it was Jefferson,
Yeah, but they have something going on with the pedestal.
right?
They have to,
Right, because like even if we switched it off, it would still have a problem. Well, what I was getting at is, so with all that being said, wouldn't you want to unplug like all the boats that are on that pedestal?
Well, you'd have to
Right.
unplug everything, yeah. That's where, it's a little unclear to me. It feels like just shutting the power off at the pedestal would normally be
Yeah,
an
it's
appropriate
efficient.
and safe enough thing to do.
It in conjunction with the shock alarm.
Yeah, with the shock alarm, yeah.
But otherwise, it wouldn't be.
Oh, no, you
have
always have to
you
use
have
the
to unplug
shock
everything,
alarm.
no matter what.
Yeah, and straight up unplugging them is pretty darn good. Although if even if you unplug and you're still detecting, that means you have an issue with your pedestal.
Which we've seen before.
Yeah, and
Yeah.
it could be like shooting. You might have a short over here on the hot, and it's going over to that one, and maybe it's ground.
Oh, so it's just jumping.
taking a whole nother circuit to a whole nother pedestal or
Yeah.
another
Okay.
ground.
That makes sense.
So
Okay.
certainly that can happen too.
Okay.
So there we go, and that's a little touch, and at least one way that these kind of nasty things can happen.
Mhm.
So, like leaving the shock alarm in the water really isn't entirely useful.
Well, you'd be sitting there watching. Oh, look at that!
Yeah.
So
Right,
turn it on. Zzz, zzz.
Right, but
That
you'd
should
already
go-
be in the water, and
Yeah,
it
would have
would.
no knowledge of that.
Yeah, it wouldn't. Yeah.
Yeah.
Yeah, I wouldn't really.
Okay, so what did you learn in that report?
Well, this report was very nice here. Now, it was interesting. This was a report here with an intact electrical system. This shows you how things really work better, probably, than what I had here. But you can see here that here's where the the engine. Well, they show this here, the engine being the connection to the water here. An engine microwave. They show the circuit flow and the way things are going to work. So I found these to be pretty nice little diagrams, actually. And here's when you get a nasty shock, a nasty fault here.
Mm.
Your hot shorted to the microwave, and the microwave is attached to the ground, and bzz, it goes right on back there, right through the water
Mhm.
to the pedestal over this way.
You should probably keep these.
So
in
this
the
will be
car.
if this is the case, even if your ground is completely good back here, you will get some current go. Like I had mentioned a little earlier, the resistance path is similar to, well, which way is the current really going to go? And if you have a real easy path, most of it will just go back to your pedestal directly, but you will get some, they call it stray current. It'll be kind of lightweight stuff. It's probably not going to, you won't even feel it, probably won't have any problem. If you're fully grounded, you're going to be okay. But then again, if your ground, safety ground is blown, now all the current goes zipping back through the water.
Mm.
Goes up the hot, you got your short, bzz, and on in. But I got out of that report, first of all, it's worth the read anyway.
Yeah.
but is the fact that, yeah, the shock alarm is not enough by itself. And
Yeah.
I was thinking, why the heck is that? Why is that not enough? Well, it's not enough because of the fact that you can have a switch circuit within your boat. And when you have a switch between a hot and the load, your shore can be on this side, which is, you know, always hot, which in which
Right.
case the shock alarm will always detect if you get a short there. Or it could be on the other side,
Yeah.
which the current won't even be flowing until that switch is closed,
Yeah.
whether it's a bilge pump, temperature,
Or
or
somebody
somebody
goes in and
throwing out
flips on a switch, right.
Exactly.
So did it talk about the distances it could go?
I didn't get that
Oh, it
far.
didn't. Oh,
Yeah.
okay.
I think they're relatively not. The distances are not really very big. You know, we're talking about 20 feet kind of thing.
Well, because one time we did find it, and it was coming from a boat. There was the boat, an empty slip, and then it was in the boat one over.
Yeah.
But usually when I have found it, it's been in the same slip. So there was just that one time.
Yeah. Well, that's, you know, certainly possible.
Yeah.
Yeah.
But I wonder if there being an empty slip made it so we could travel
Made it
further.
easier, like
it
less
had less to go
resistance?
to. I don't know.
Well, you know, if the middle boat had a proper ground,
Then it could go to that.
then it would
Oh.
short circuit the stray current. It might allow. That's the problem. Is that when you're talking about current going through water, it's very unpredictable.
Chaotic, yeah.
Because if there's some salt in this area, maybe some silt or who knows what, you know, the water current
Enough to
conducts a lot
kinda
better.
slow
But
it
if it's
down.
stilled over here, well, it's not going to travel through that at all.
Yeah.
So it kind of depends on the nature of your water and how scuzzy it is, what the minerals are in it,
Yeah.
what's been going on.
So if someone's anode looks really bad, what does that mean?
Their anode looks bad,
Yeah, like all chewed up.
you got to replace them. Anodes they call them sacrificial.
That
anodes.
happens normally.
Yeah, that's a
Well,
normal
one guy
thing.
said his had just been replaced and it already looked horrible.
Well, then
Does that mean
it's
they had
probably means he has a
issues?
circuit. He
Yeah.
probably has a circuit problem because the anodes they're sacrificial as current goes through them. They lose little bits of themselves,
Yeah.
and the more current flows through,
The faster they'll
I would
degrade.
think. I'm not really 100%. I'm not really an anode dude, but I would think certainly the more current your anode has to carry, and it shouldn't be carrying any. It's
Mhm.
there just because you need safety here.
So, but how? So the wire's not in the water. So how can it get from the boat back to the pedestal if it's going through the water? How can it reach it?
Back to the pedestal.
Yeah, if there's
Well,
an issue,
see, it
they
doesn't
can't get back.
necessarily. Here's the thing: it doesn't really have to go to the pedestal.
It just goes to ground.
It just goes
anywhere.
to ground anywhere. Yeah. So if there happens, its easiest path to ground.
But what if it was shallow water? Would it just go straight down?
It might, and it
No
might
way
not.
to know.
You don't know.
Yeah.
That's the problem.
And if it was a
is
metal
it's
dock,
very
would that be more
unpredictable.
likely? Or hard to say.
Metal dock.
Yeah.
I would think a true metal dock where it has, let's say, steel pilings
Yeah.
pounded in far enough, and they always are.
Mm-hmm.
That probably would help ground the
But
water.
it'd still be on
But
the way
even
there.
so,
That'd be
it's
a
still
problem.
yeah, exactly.
Well, it's
It's over
traveling.
there, and it still might not be the
You
easiest
intercept it.
path. Yeah, it may or may not be. I think once you enter the water, and once the water becomes part of the circuit, like all bets are off. You can
Okay,
go
you don't
anywhere
really
and
know
do. Yeah, not really.
Okay.
It's not going to go real far. You could say that.
Mm-hmm.
It's going to find the easiest way path. You could say that, but you don't know what the easiest way back is.
Yeah.
Yeah.